Alright, boys. Here's where we're at so far. So I had to add a bigger set of pulleys for right here. The first down gear has to be pretty big because the motor needs to reel in a lot of string. So I had to tear out the old setup and put in this setup where they're more spread out, and this one specifically is bigger. So I had to back it out, which means it also overhangs a little bit, sticking out from the motor's profile, but that's okay. It's just a little bit. I already checked the CAD model, and that's space we can afford to give up. So I'm okay with that. And because it's so big, you can see I already got the bottom wound up. Um, it's got about 5.5 to 6 feet in there, and we only needed about 32 inches, so like 2.8 feet or whatever. So we've got a lot of extra in there. Um, but what that's going to mean is if you look at the diameter of this output shaft and then the diameter of this, if this diameter is like, I don't know, like 10x, the output shaft diameter, that means it's a 10 to 1 down gearing just by the first pulley. And so if we get even 10 to 1 and then times 2, that's 20 to 1, 40 to 1, 60 to 1, 80 to 1 is what we would get if the rest are 2 to 1. And that's more than we needed. 80 to 1 is more than we needed. So this 10 to 1 is a fantastic asset for us. So yeah, that's where we're at. I just want to show you guys how I'm doing it because this is pretty hard to hard to do. It takes a lot of skill to build something with enough precision at the scale. Right now, I'm building the plastic discs for the output shaft of the motor. I determined after measuring the distance between all these pulleys that it has to work with, that it has to be 5 millimeters in diameter. So I'm going to draw a little dot and then measure 2.5 millimeters from the dot. I didn't want to smudge the existing ink that's not really dried onto here. It's not drying well. And so I just flipped it upside down and I can make the other half of the circle. It's pretty soft. There you go. Just last night. Thank you, camera. Ready? Go. Okay. Dang. That thing's lost. That's the trouble with very small parts. If you drop it, it's like, okay, it's gone. Especially when they're clear. try to find it, but it's not looking good for that part. Hi, Pulley. What's up, guys? I'm working on my robot here. I'm making a pulley system based on, or a pulley downgearing system. Trying to cut out a little pulley, measuring out little dots from a center point. 2.5 millimeters from that, forming a radius. The point of downgearing with pulleys is to cut down on noise compared to metal gear downgearing. So the pulley downgearing will work the exact same way as gears do, except instead of cogs on the gears causing the next gear to turn, it will be rope. Alright, here's my circle I just made. If my camera will focus. Camera won't focus this time. It's alright. It's just a circle. I showed you guys the last one. Okay. So just wait now. Oh, see the circle. My civic duty? I don't know what you're talking about. What's civic duty? Feed the poor sometimes, although I don't want to get into details about it. I'm not supposed to boast in your good works. Voting? I'm not a voter. I tried voting during Corona one time, I think. And they never mailed me the ballot, even though I signed up for it. Oh, oh yeah. I don't know why I even have these on here right now. What are we working on? A pulley-based downgearing system for a BLDC motor as a replacement for a gearbox because gearbox is too noisy and too big. This is going to be a miniaturized, compact downgearing system. I believe it will achieve 80 to 1 mechanical advantage, and it's going to be completely silent. This motor will be for actuating the index finger of the robot. How will you make it completely silent? You hear that? You don't. Because it's quiet. I use thumbtacks with #2 fishing crimp sleeves to create the plane bearing. Um, Nicola, you're trying to make casual conversation, and I'm doing what would amount to the level of skill of open heart surgery. I'm doing a surgery here. I'm applying super glue at the tip of a sewing needle right now. Yeah, I do think the advancements in LLMs help my job easier. I ask ChatGPT stuff all the time. I literally consider ChatGPT to be like my professor or tutor. I know it can be wrong sometimes, but I follow it. It's so much stuff. Relationship advice to business advice. I don't know. It pretty much halfway runs my life. I now even have it schedule my days, telling me what to do. And it helps me design my AI. Now, I'm not actually using LLMs as the mechanism of the AI. I'm using a hybrid AI between rules-based AI slash expert systems and machine learning. It's a hybrid. It's not one or the other. It's both. I'm not that far along in my AI development, but I have my plans in place, and I've already laid the foundations for a lot of how it's going to work. I know what to do. I have my whole journey already blueprinted. But as far as actual implementation, it's still just getting off the runway. Helping me improve my multitasking. Oh, will I be doing my 2024 year interview? I skipped that question. So there it is, guys. Yeah, I'll do that eventually. Update. Wonder if it's gonna even zoom in on this stuff. Doesn't really want to show this. Oh, would you believe that this one has 7 feet of string wrapped on it, or like 6 feet? No, it's closer to 7 feet. Look how easy that spins. It's completely silent, not making any noise at all. Spins effortlessly. Look how small this is next to my finger. My finger looks like some gigantic meat stick next to this. This is very tiny. We're working with some tiny stuff. Need a different camera? Anyways, this is the humerus. This is like where the bicep would be of the arm. You're looking at, well, you can see robot's hands kind of making a Harry Potter looking position here. Like, I don't know why that finger's moving that way. Kind of funny, but yeah, it's the hand, and this is the arm we're looking down at, and this is the bicep. Just in case you're wondering what we're looking at here. Like I said, this will be actuating the index finger doing this. Forward and backwards, actually. That's what this motor's going to do. And I anticipate we'll be able to get about 30 pounds of pulling force off this after it's downgeared. So that finger's going to be very strong. I should be able to like finger curl like a 10-pound dumbbell. Maybe. It's going to be stronger than my index finger, I think. And that's just from this little motor. This takes up less space than a servo. And a servo that took similar space as this would only pull like a pound and a half of force compared to this doing 30 pounds. So this is just a lot better than a servo. Although you could technically say it is a servo, but when I say a servo, I'm referring to a metal gear servo enclosed in a plastic box. Okay, so it's time to make the next pulley, and hopefully we'll be able to find everything. Uh-oh. Oh, I found it! I found a little paper cutout, using it as a stencil for that. I sure hope that thing's big enough. Man. We could go another full millimeter in diameter. So actually I am going to tear out that. Getting the disc size as big as possible matters a lot for making the reliability go up. I know this looks like excruciating. Like, you're telling me you're tearing that out after all that work? I have to. It's part of... I had to tear out this whole thing. I had it done, but I needed to improve it. That's just part of it. I'm not following a tutorial here. It's all my own research. You gotta reduce stuff sometimes. So I can go a full 6 millimeters diameter. Yeah, I prefer the anatomical way because when you go to actually have the robot emulate human movement, it's going to be so much easier studying your own body and seeing like what muscles activate to do what thing, as well as the AI doing that, just studying people's muscles. And it will have all the degrees of freedom of the human body this way too, which is very important. Because I want the robot to move just like a human. As much as possible. I didn't like that. I didn't like how small that last pulley was anyways. That was brutally small. See, if the pulley's too small, the string is more likely to skip off of it. And then you got a tangle rat nest on your hands. But I want to make sure the string that's being winched into it actually stays on the shaft in the slot it's supposed to stay in. It can't become derailed. So the more overlap the plastic disc has to guide that string and keep it in track, the better. Normally I'd use a protractor to create a perfect circle, but I don't even think a protractor can work at this tiny scale. So I'm using a 0.25 millimeter precision micron pen, 0.25 millimeter line. It's a pretty cool pen. It's very precise. Perfect for this type of work. And I'm using the Dare ruler I got in 5th grade, I believe. I still have it all these years. Technically, you need 4 muscles just for the index finger. 1, 2, 3, 4. Yeah, I'll be using 4. I will. You're right. And CAD, I already planned for that. So 4 of these that you see will be mounted to this arm. I won't even be able to fit all the motors, even as downsized and downscaled as I have this, I won't even be able to fit them all at the arm. Some of them are actually going to go on the back of the robot and the lats area. That's how many motors are required just to do the hand and finger actuation. Actually, no, you can cut out one of the 4 by using one motor to actuate these 2 joints together. Because if you bend your finger, they both bend proportionally at the same time. Now, some people can isolate and just do this, but it's hard to do. Most people can't even do it, and I don't think that's necessary at all. So you only need actually 3 to get completely matching human performance. Well, you kept it simple, so people won't try to rip your head off like me. People are really mad at how complicated my goal is, my approach. They think it's just impossible and stuff. So, I'm facing a lot of criticism, and it also takes way longer. But I think it's all worth it. Because if I pull this off, it's going to be really, really, really awesome. And awesome factor is a big deal to me. It's so logical. Well, thanks for saying that. Yeah, there's a mix of opinions. Most people think this is a fool's errand, a pipe dream, very unrealistic, and a waste of time. They wish I would just build something easier. But it has to be sufficiently challenging to capture my attention for decades. If it's too easy, I just will never finish it. I'll move on, lose interest. I'm going for like Hollywood science fiction level quality. That's what's fun to me. Make science fiction become science reality. That gets my blood pumping. You're a believer? Thank you. appreciate that. Oh, you're in a rare minority. Fortunately, I have a thick skin, so all the hate I get bounces off. It just motivates me. I use it as motivation fuel. Oh, the sun visor? Yeah, I did a great fix on it, but unfortunately, she got rid of that car later. So that work benefited the junkyard, I guess. I think she junked it for cash. So that was kind of a waste. I mean, she used it for a little while, though. She has a nice car now. Barely needs any maintenance. It will one day, though, but so far it's new enough to be pretty maintenance free still. I'm able to do some crazy nice precision work using this visor I wear. Being able to see everything zoomed in makes all the difference. I'm able to get crazy good tolerances on stuff like these cuts. Uh-oh. No. Oh, I found it. Oh, I found it. Yes. Usually, if you drop something this small, it's over. Especially with it being clear. I don't think I like this one. Let me test it. Well, that looks pretty good. Huh. Well, it's still very accurate, I guess. I don't know why. Uh, I don't know why. I don't know. I guess maybe that's good enough. Doesn't look like a perfect circle. It kind of looks like an oval, but I think I might be being slightly too picky. How's the project going? It's going real good. Is this a motor? Yeah, this is a BLDC motor, 2430 motor, and I'm making a Pulley based down gearing system, 80 to 1 mechanical advantage, using thumbtacks, number 2 fishing crimp sleeves, and polypropylene plastic. Got it from strawberry containers from the grocery store. See ya, call me. Is everything repurposed? Yeah, pretty much. Trying to use things that are affordable, easily obtainable, combining them in novel ways to make technological leaps in an affordable way. Well, thank you, Logical. It's funny you say that's even more impressive, but that makes you a minority because a lot of people say that's unprofessional and it's amateurish, and I should be machining all these things or having it made at like a big company that will make microscopic parts for you for like hundreds of dollars per microscopic item. I'm just like, I'm not working with NASA's budget, nor will anybody that may want to follow my footsteps and make their own robot using the tactics I'm using. Kind of a big part of my goal from the beginning has been to be completely open source with the hardware and make my it's accessible by sharing how it's done at a very high level, not just like a toy robot, but like actual cutting edge, industry leading level robotic progress, all open source. Man, is that satisfying? What a great fit. I'll let you guys watch this thing slide on. This is like MVP tool right here, by the way. I repurposed an X-Acto knife. I put a sewing needle in the tip instead of a knife, and this thing is like game changing for working with tiny stuff. I use it to apply all the super glue, for example. It really helps out. This has to be just the right height to line up with this group of discs right here. I'm touching the black thread on it. This thread has to be pulled onto this shaft like a winching action. Oh, you're calling my tool making genius now. You're being very positive. I'm not used to that. I've been called an idiot, retard, failure. All talk. Every day, all day, I've been abused over this project. I basically think I'm the dumbest roboticist on Earth and the worst roboticist on Earth. How many more discs? I already got the ones for this thumbtack and this thumbtack made. I just slid them off. They pop right back in. I just moved them out of the way while I work on this motor shaft in the center. It's more impressive than the Tesla bot? Okay. Now that is a compliment. Wow, thank you. That's crazy to hear that. It just shows everyone has their own opinion and perspective when it comes to like what they think is impressive. Here's another little trick you guys might like. I put the super glue in the cap of the super glue accelerator spray can. I just put it in there so that when it inevitably falls over, it's not falling onto the ground. That saved me a million times just to keep it that way. And then as far as how I use it, I just put a single drop onto a piece of paper, and I just do it in rows so I can keep track of which drops are dried out. And I just dip the tip of here, just tiny little bit on the tip of the needle, and now I can glue down the part. That's all the glue you need. I mean, we're talking about some tiny, tiny stuff here. It's actually kind of hard to turn this thing. Let me see if I can turn it with this needle. Needle nose. There we go. I mean, normally I wouldn't think of something like that, but necessity is the mother of invention, and after dropping your super glue a million times, you're like, you know what? There's got to be a better way to do this. It's funny how much like surgery is. I actually wanted to be a surgeon because I had steady hands and really good eye-hand coordination. I went to school to be a surgeon, but it turns out I still kind of get to be a surgeon, a robot surgeon. Like you literally need almost surgical skills to be able to do this. What is the bright light you use? I'm looking for a good one. Um, it's just a lamp that I don't know if you can see this. Mm, right here, you can see I have a lamp I connected to my chair, and then this lamp I'm using as a camera mount. I could turn the light on that one too. Then I'd have two bright lights. Feel like a proper. Actually, that's pretty nice. I have like a full surgery level lighting now. And I got my visor on so I can see like zoomed in. My hands are pretty shaky. Well, one thing that helps is you always want to put your pinky finger onto it and use that as a brace. It's usually, sometimes even two fingers, and then after you have that brace, it kind of like takes the shake out of your hands. If I like just try to do it like this, like that, my hands would shake too. But you brace and then steadies your hand. You like lead, so all the weight of my hand is like held now, and now I'm just moving these muscles. That's it. So this stabilizes a lot to stick some part of your hand against a steady object. So that's a trick to help you if you have shaky hands issue. All right, that was done. It's perfect. Perfect. It's got half a millimeter clearance on the bottom against this particular string that goes under it. This string that runs this way. That string's lashing this thing down, so it's fairly solid against her. It has some wiggle this way, but not up and down that much. It doesn't have to be perfect on that regard. That doesn't really make a difference on performance, I don't think. So I just did minimal lashing down. Now I gotta make the next disc, another 6 millimeter disc. Okay, so that's here. I like this video would be right for people trying to reproduce this type of output pulley system. Because I think people might try to reproduce it if it works well. They'll be like, I want that. That'll help on my project. It's very compact. It'll be silent. It'll be very strong for its size. Pretty much unmatched in my view. I can't think of anything that would be better, really. As far as silent and compact, extremely powerful for a small size. I mean, it's like ideal. Now that's if it works. Will there be something I haven't thought of? Will it just constantly get tangled up? Will I be able to keep tension on all the strings? Will the strings fail prematurely? Will they just wear out fast? There's so many questions. I don't know. So that's where experimentation comes in. Some people said maybe the thumbtacks will like bend and snap, like not be able to handle the forces involved. But I disagree. I think the thumbtacks will be solid enough. They're not really facing too much in the way of forces. Most of the force will be spinning. It'll just want to spin it. It's not going to want to like tear the thumbtacks sideways. It's going to want to make the outer sleeve spin. That's it. I don't think the thumbtacks will be dealing with a lot of forces placed on them to press them sideways and snap them in half. I don't think that type of force is involved that much. Unless if the spinning action were to be like hindered somehow, then that might yank this thumbtack sideways hard. But as long as they're spinning freely, I don't think the thumbtacks will be handling that much forces to the side, trying to rip them in half or bend them up. Okay, this one just turned out way better, easier. It just looks more rounded. I guess the first one was good practice. This one just came about a lot easier. If you're wondering where I'm getting a lot of the recent hate, I posted my project on the EEV blog forum, and I've been interacting with a lot of electrical engineers, I guess, on there. Some of them worked in aerospace, and so they are quite demanding, and their standards are pretty high. And they're very, very skeptical. So it's a hard crowd, I guess you could say. So if I can convince them, I can convince anybody. But they're still demanding results before they'll believe it can work. It's funny, they want me to prove it works before they'll believe it works. It's like, don't they have any ability to like visualize whether it would work? Is the black thing a bone? Yeah, this is a humerus bone, which is like your bicep bone, and it's wrapped in adhesive transfer tape and heavy duty black nylon cloth. It's called 1000 denier nylon fabric. It's kind of like book bag material for children's book bags, like tough book bags, like high school age book bags. So I could sew right into it using suturing techniques to mount components onto that. When did you post the last update? Well, on that forum, I've been posting updates daily. I guess the most recent one was today. I've been doing a lot of updates on my blog and my website as well. My YouTube updates are weekly more so, but they're delayed. So like, there's like a 9-month delay between when I make a YouTube video and when it actually goes live, or maybe even a year and a half delay. The website's artbyrobot.com. I've been working on this robot pretty much like a full-time job the last few weeks. I have a lot of other things I'm putting off by doing this, but I think every now and then it's good to just dive in on the robot for a bit. Uh-oh. Uh-oh. Part just flew somewhere and it's gone now. I think the odds of me finding that are extremely tiny. I'm not even going to try it. I'm done. No, that thing's gone. It's over. Time to make the next one. Notice me stream more? Yeah. A lot of times I don't stream, but streaming takes more energy and time away because you got to edit all the video footage after too then. So it's kind of cutting your speed way down. So I only stream like very important stuff that I have to document. I just have so much less time than I used to when I was in my 20s and stuff and didn't have a family and kids. And so I have to be more careful about like maximizing copy time, I guess you could say. So I generally won't stream when I work on it. Unless, like I said, it's really something super important to film. Actually, I got into this feverish pace with robot building because I was going to follow on with the Hope Light robot they made on YouTube by the Robot Studio, but he just took too many design shortcuts for me, and I decided to kind of go with my own designs after a while, but try to keep up with him at pace. And trying to keep up with him motivated me to work faster for a while. It's not sustainable to work at this speed. I have too many projects I'm neglecting, but at least for a while I can do it. Like I have a rental property I need to fix up from a house I bought, and I haven't been working on that at all. It's funny, I've got like 1/10 of a millimeter clearance between between these items. It's crazy to be working at those tolerance levels. Just working by hand by eye, like not a machinist. I don't know, it just seems like really intense when you're dealing with such small clearances and stuff. But I got it lined up perfectly. Okay. Perfect, I got it. Alright, so the next step This will never cut this thing. Oh, that was on purpose though. Let me get you guys in on this better. I had a problem cutting it. It screwed me up. The scissors wouldn't cut it. Nice, okay. I have to glue the first couple wraps of it onto the motor output shaft. So I'm just turning it like 30 degrees or 15, 20 degrees, and then gluing it, and then turning it again, and then gluing it again. I gotta pull it taut each time I turn it. Now I apply the glue to the string, pasting it to the shaft the 401 glue and the tip of a sewing needle. It's coming out great. Hmm. My roller away. Okay. Huh. I want to fix this thing. let me put a little bit more glue, and then I will have officially a break. I gotta go get food. But this is big though. It's a great pausing point because I got the string mounted to this output shaft of the motor perfectly. And I think it is glued enough, pretty much. Because the motor only puts out half a pound of force from the output shaft. Well, it might be 1 pound since it's wrapped so close to the shaft. It's supposed to be 1 pound at a centimeter weight. No, I think it's 1 pound at a quarter centimeter weight. This is like less than that, so it might be a full pound. Maybe half a pound if you're a quarter centimeter weight, or 0.48 pounds at a quarter centimeter. This is like an eighth or 16th centimeter, so it might be a pound, maybe up to a pound and a half. A pound and a half of force is not that much, so I don't think it can pull free the glue on this string. So I'll just show you guys the completed setup here. Okay, so we got, show you here. So we got all that glued in there, and you can see the string passing between these two pulleys. So this little pulley has to move how many times to turn this big pulley? Well, if you measure the diameter of this shaft, it's probably like maybe 9 times the diameter, or maybe 1, 2, 3, 4, 5, maybe 6.5, maybe 7 times. So that will be a 7-to-1 mechanical advantage as it turns that. And then we'll have another string coming up here. It goes from skinny to big, it'll go back to skinny again, and then it'll go to a big one again, and then skinny, then big, and so forth as it wraps around always. So this is just the first phase of the downgearing, and then it'll jump to right here. Off of this second tier, it'll jump over to here, where it'll get big again, and it'll jump to here, skinny again, and then it'll jump to here, big again, and it'll jump to this back one, skinny again, etc., all the way around, all of them. And each time it will get more mechanical advantage for a total of maybe, let's say this is 8-to-1, and then it'd be 16-to-1 if this is another 2x, 16, then it'll go 32, 64, 128. Might even be able to get more if we go more than 2-to-1 on these smaller ones. But you can see this set of pulleys is much bigger. So it's giving us an 8-to-1 mechanical advantage. It's a much bigger one. But yeah, you can see the little string right here that crosses from the shaft to this first pulley. You can see it. So it's already got a little bit wound up and glued on real good. And so as this motor turns, it will turn this pulley right here as this motor shaft turns. So it's looking good. These two thumbtacks don't have their pulley systems on them at the moment, but I can just pop them right back on anytime. Which I'll do real quick to show how it will look. If I can get it off of here, what the heck? What the heck? I just broke one. There's glue. that got onto here and glued the pulley to this tape. That sucks. I don't know how glue got on there. That's annoying. Oh. Good. For some unknown reason, these got glued down to that other thing. Anyways. You can see the bigger one moving as I do this. Watch this. It's moving it. Anyhow, might work in theory. I mean, it's definitely going to need to be kept under tension at all times. Because the tendency is like, I'm noticing as I turn one, the other one like doesn't want to turn, and then suddenly it's enough force to turn it, and it turns jerkily, and then that jerky turn causes it to overturn, and then that loosens the string. And that string, once loose, could jump off of the discs and get out of alignment, so to speak, and then get things tangled. So we want to maintain tension in the system at all times. I'll have to have a spring tensioning system somewhere on the string, somewhere at the final output string, in order to do that. And I already have some ideas of how I'll pull that off. So hopefully we'll be able to, I mean, we will be able to resolve all issues like that. Not hopefully, we will. I'm sure. What's up, Carrie? Alright, so that was my update, and I'll take off. I'll show you guys more. Probably the next update, I'll show you guys, like, I don't know. I just gotta line the rest of these up. It'll just be repeating what I just did. We just gotta line everything, and then the motor will be able to cause all these to turn at once. Forward and backwards down gearing, 60-41, and maybe even up to 120 to 1 mechanical advantage, depending on how thick I make each of the windings and stuff. It'll be varying too. Like when it first starts out, it'll have more mechanical advantage than later, I think. Yeah, well, alright, peace out.